Hello, everyone, and welcome to today's webinar, Ask Me Anything, Connect Any Application to Any API with Autonomous REST Connector. Now, let's get started by quickly introducing today's panelists. First, you have me. I'm Joelle Andrews, a Senior Product Marketing Specialist for Progress DataDirect, and I'm also going to be today's moderator. I'm joined by Dennis Bennett. Dennis has over 20 years of experience in working with companies to help solve their data connectivity challenges. In the past, he's worked as an application developer, database administrator, and QA engineer. At Progress Software, he is a principal sales engineer for the data connectivity and integration products. We also have Ken Butler. He's a product manager at Progress, focusing on the data connectivity and integration markets, along with new product development. Prior to his role at Progress, Ken helped lead and bring to market new product initiatives for SAP and SaaS for their data integration, data governance, and data quality product portfolios. I'm going to start by turning things over to Ken. Ken, you want to get us started?
Thank you, Joel. I have a quick little presentation here to just cover some of the basics of what the Autonomous REST Connector is and to highlight one of the major features that we've delivered to the market a couple weeks back. And so what is the Autonomous REST Connector? The Autonomous REST Connector is an intelligent, customizable data connectivity solution enabling businesses to build and deploy REST API-based data connectors without coding. Now that may need a little bit more of an explanation, so we can kind of dig into exactly what that means. And so traditionally, SQL has been a common approach. SQL access to data has been a common and traditional approach for decades. Enterprise applications for analytics, BI, and data management all operate relatively the same. The application makes a SQL request using ODBC or JDBC to a backing data store, and the data is returned, updated, created, or deleted. There are a few common pitfalls when needing to support this model. First, each one of these applications has a set of users that are using more and newer data sources. SaaS applications, platforms, and operational databases are modernizing to expose data using REST APIs. The list of REST-based data sources that these users or your customers require grows every year, and it's hard to keep up. Second, given the breadth of users, it can be difficult to maintain so many point connections across so many different data sources. Who is accessing data and what they're doing with it can be a hard question to answer. And most importantly, standardizing how data is being accessed, such as retrieving the current list of customers that are active, is almost impossible when users have direct access to the database or can perform any ad hoc query that they want. So organizations, enterprise applications, and SaaS solutions are modernizing how they are allowing their customers to access and leverage their data. This new approach is to expose data as services, as opposed to allowing applications or users to directly go to the data source. This is being done to standardize how data is being accessed from a governance perspective, but also allows for a standard way to consume the data using API calls. Take, for an example, an enterprise that stores customer data in a relational database. Instead of allowing each application to issue a SQL query that may be performant or not to the customer tables, they may choose to implement the REST API for requesting the list of customers. This also ensures that the data is returned, is standardized, and that consumers are getting what would be considered to be a valid set of customers. So how does this affect what is considered to be the common approach to SQL-based tools accessing REST data? SQL-based tools like Power BI, Tableau, or others do not effectively work with REST APIs. And this is where the Autonomous REST Connector fills the gap. The Autonomous REST Connector allows the conversion between SQL and REST, so it acts as a bridge, so that there is no loss in functionality when enterprises or applications modernize to leverage the use of REST APIs to expand data access for their consumers. Now, what's really driving the push towards REST APIs? And there's really a few reasons why this push is happening to either consume data or share data. The first one is mainly due to security. SaaS applications view it as a security concern to provide direct access to their backing data store. REST APIs enable SaaS applications a controlled way to share data with their customers. Regulatory requirements such as PCI or GDPR require you to treat PII data in an especially sensitive way and controls who can get access to it. Related to security, SaaS applications and enterprise applications contain data that is valuable to customers, that customers want to leverage for BI or analytics. Modern SaaS applications expose their data via REST APIs for the ease of consumption, but also for security and regulatory concerns. Workday, Dynamics 365, SAP, and a host of other large enterprises that have built cloud platforms to support their business all use REST APIs to share data. It has quickly become the common and standard approach to exposing data. There are also tens of thousands of APIs available for public consumption. This data can be used to enrich enterprise data or find valuable insights for analytics, but it's locked behind REST APIs without an effective or efficient means to consume that data. And we'll dive into how Arc can be the bridge between SQL-based applications and REST APIs next, and look at how the Autonomous REST Connector can make the consumption of API data even easier. So let's look into how do we actually build a connector using Arc in an intelligent way without needing to code. So Arc is mainly driven by a REST configuration file. And this REST configuration file really determines how the data can be formed in a relational model. When the downfalls of working with JSON formatted data is that it's not naturally in a relational model. So what the Autonomous REST Connector can do is it can intelligently sample a response from any API that we can consume, and it turns it into a REST API. It turns it into a relational data model. The next step is to tune that. Once we have our endpoints configured with the Autonomous REST Connector, we can make changes to the data model that was dynamically and intelligently generated and make adjustments so that our consumers can have a more effective data model to work with. We can change data types, column names, or table names. And after that, we can validate it. Within the UI, you can validate the data that you see in real time after you make these adjustments or add any different endpoints that you have. And finally, you can deploy that. And this can all be done without needing to code a single line of code. And so the Arc building a connector to a REST-based data source usually requires a custom development initiative that will be a single point solution that won't scale across all the different REST APIs that you or your customers need to access using SQL-based tools. The main goal is that the Arc UI drastically reduces time to market, development costs, and ensures that your developers are focused on what's most important to your business, and so that we can take care of connectivity for you. And so if we take a look at the configure process of the Autonomous REST Connector UI, this is mainly about creating that data model. And so on the left-hand side, we have an example of a JSON response from a simple SpaceX data API that's a public API that's available for anybody to consume. And so effectively what we do is we take this response on the left-hand side, and we can turn this hierarchical data into a relational data model. We make a best guess based upon the table names, the column names, and the data types that we see, and we turn that into a generated relational model that you can work with within your SQL-based tools. On the tuning phase, this is mainly about customizing that generated data model that the intelligent sampling process created. Here you can modify the data model, such as editing column names, table names, and data types. You can add and remove query string parameters. From a performance perspective, you can add paging capabilities along with pushdown capabilities. And you can import an existing recipe so you don't have to start from scratch, and modify that if there are any changes to the API itself. And finally comes the validation portion. Validation is one where you can actually take a look at the JSON responses and the data that's being viewed in a relational model, and take a look at that from the UI perspective. And then we have a way to dynamically generate a JDBC or ODBC connection string. And so you can easily leverage the Autonomous REST Connector with your created REST JSON file and use this to deploy it into any tool of your choice that uses ODBC or JDBC. And just a quick preview of this, since we kind of had a little bit of description here, and picture is generally worth 1,000 words. but this is just a quick preview of what the Autonomous REST Connector UI looks like that Dennis will jump into and provide a demo. So with that, I would like to pass it over to Dennis, and so he can actually show you the magic of what this user interface can do.
Okay, hey, this is Dennis. So actually, I am going to show that same SpaceX API that Ken was just showing you in that PowerPoint. You can see we're up to V4. They've been changing it over time. And I'm going to use the Autonomous REST Connector user interface to sample 3 of these different endpoints and actually build a JDBC driver from that, and then turn around and use it in a couple of different tools. So the way the Autonomous REST Connector UI works is, right now it is a JDBC driver, but I invoke it just by double-clicking on the jar file, and it will open it up in a browser window for me. And I'm just going to give it a project name. And I'm going to give it the base URL. This is actually useful, especially if you have an API that maybe you want to go through development, through QA, through production, and the base URL will be different. This is just a way where you're able to set it up, the configuration file, and just reuse it for all the different environments. So I'm just going to go ahead and grab the base URL and paste it in. And I'm going to go ahead and save it. And now I'm really ready to start sampling some of those different endpoints we looked at. So I'm going to grab launches first. I'm actually going to pull 3 of them. And so launches, and I'm just going to say, I'm just going to use a query parameter, just saying pagination is false. And I'm just going to call the table name that is going to be generated launches. And if I go ahead and send this, he's going to go ahead and hit the endpoint and bring back the data. And he'll show it in a SQL view first. But if I wanted to, I can look at the JSON data that came back. This is actually, the Autonomous REST Connector has a SQL engine, which will parse SQL and turn around and create the appropriate REST request. As Ken showed you, sometimes when we sample one endpoint, depending upon the complexity of it, we may end up with multiple different virtual tables. And in this case, we can see that launches actually has a bunch. It's a fairly complex payload coming back. So we're going to normalize that out into separate virtual tables. We'll build the foreign key relationships between those two and between the different tables. And this really makes it a lot easier to use it with a tool that is used to dealing with a relational database of rows and columns. So the other thing is I didn't show you is this is actually a fairly simple authentication with none, but we'll also support basic auth. We'll support URL parameters, even OAuth 2. So again, this is a real simple one, but if I wanted to, pretty much anything that you'll run up against, the idea is that we'll be able to support it for you. I actually put a query parameter in that sampling process, and you can see it picked that up as a potential filter parameter. So if I sent something in specifying pagination with a different value, he would be able to go ahead and push that down. Let's go ahead and add another endpoint for this. So I'm going to grab another one, and I'm going to grab launch pads. And if I do that, I'm just going to give it a name and go ahead and send it out. And you can see, again, he went out to get launch pads, and I've got a few different endpoints in addition to the ones I already had. In this case, I've got a table called launches underneath it, and maybe I'm going to find that to be confusing. So if I wanted to, I can change the table name, and maybe instead of launches, I'm just going to call it launchpads underscore launches, just to know where it's actually tied to. It just makes it easier for me. And if I wanted to, I could do things like go ahead and grab in the launchpads, for example, I can go ahead and determine which or specify which of these column attributes. Like Ken said, I can change those. So I might decide, ID is actually a primary key and potentially a filter parameter. So I can go ahead and save that information. And if I wanted to, this particular endpoint, if we look at it, you can see I can grab all of the launchpads, just with a simple get. But if I wanted to, I could also specify a single one by passing an ID parameter of a specific launchpad. So I can tell ARC, or the Autonomous REST Connector, I can tell it I've actually got a parameterized path. So in addition to maybe just, if they don't give me an ID, I'm going to get the list of all of them. But I may want to just focus on one. And to do that, I just would specify a filter parameter here that's part of the parameterized path, that if they give me an ID, if that's passed in, select asterisk from launchpads where ID is a value, rather than doing a generic select for everything, I'm going to specify and just get one particular one. So that's going to help with performance. So anytime that a REST API supports filters, we're going to do our best to take advantage of them and push the filters down. In this way, the performance will be best, the amount of data going over the network will be minimized. But in some cases, if you're using a tool, for example, say a Tableau, it's going to generate queries that are probably going to be beyond what the REST endpoint can support. So in this case, we'll push down the filters we can, but we'll augment the capabilities of that REST API with our own SQL engine. So if there's post-processing filtering to be done, we can take care of it ourselves in the Autonomous REST Connector. So I'm just going to go ahead and grab one more endpoint, and I'll grab rockets. And I'll just call it rockets. Another thing to point out, these are all gets, but it's not uncommon to support a post. This would not be a post to actually do an update. Autonomous REST Connector is select only, but this is there are many REST APIs where the filters are actually in a post body, and we're able to support that. So I can go ahead and send that down, and you can see I see data back, and if I wanted to look at the JSON, I can do that. Another thing I didn't mention is we support different pagination scenarios. A very common one is row offset, where we might want to request the maximum page size that's available, and basically tell it the offset parameter is this one, and start at offset 0, and keep traversing, keep sending different REST requests down until we get all the data. So pagination is supported, row offset, page number, and also next page token. So I can do that. And when I'm done, and I'm just going to grab these three, I can just download my REST configuration file. This is that file Ken was talking about. Before I get out of here, let me just show you an entity relationship diagram, just because we actually sampled 3 different endpoints, but you can see we end up with a lot more tables just because of the complexity of data. And this is just a way to help you, just see what was done here. This is something I find useful. The other thing is, Ken talked about generating the JDBC URL. So another nice thing I like about it is, in addition to the mapping and sampling process, I can go ahead and just build the JDBC connection URL. And I can do things like, for example, if I want to look at performance, we have parameters. And in here, you can see we have built-in help online help, which is also real useful. Something like read ahead, if I have pagination where I might be able to have multiple threads requesting data to greatly speed performance. And, again, it's only pagination in cases where we can go ahead and divide the workload up. But you can just see these things are all here. If I want to, I can turn on some debugging records or debug record here, where I can get some useful information, where I can see the SQL that came in, I can see the REST request that was generated, I can see the HTTP response code that came back. So it's really useful, especially as you're getting started with mapping a URL with a REST request. So let's just look at what was generated here. So here's the file that was just created, and I'm just going to open it up in a text editor. So this is kind of what happened kind of under the covers. It's built this information for me from the sampling, where it grabs the column names, it grabs the data types. Prior to the Autonomous REST Connector user interface, you would have to do the sampling process and then go ahead and hand edit this file. So the idea with the Autonomous REST Connector is we're trying to make it easier and kind of, people talk about democratizing data, making it easier for the end users who need to get access to the data and do things with it, make it easier for them. So really at this point, I can just grab this information and plug it into a JDBC URL. And I've got one over here. I'm just using Squirrel SQL. And really, if we look at it in an editor, basically here is my JDBC URL, and I think I have it over here just to look at. So you can just see I'm just doing a connection to the Autonomous REST Connector, and I've created a data set with that information we just looked at before, with the Autonomous REST Connector REST config file. And the only other thing is I turned on debug recording just because I find it useful to be able to see what was happening. So, if I go back to Squirrel and I've already got a connection here. You can see this is one where I actually mapped all the different endpoints in that in the SpaceX. So you can see what it looks like. There's launches. You can see the row counts, information about the columns. You can see the primary key. You can see the information we export for foreign keys. And I can turn around and execute some fairly complex SQL against it. So I've got one here. These are just things I actually found generated in Tableau. So if I run that, we can see what comes back from that, and you can see we're doing, in this case, just a single join. This one over here, we're actually doing a three-way join. And the last thing I want to show you is I built a workbook in Tableau using this data source. So if we look at it, I'm mapping those tables we looked at before, the three, and we can see the information as far as the relationship. So Tableau is actually able to do a join between the different REST endpoints that we've mapped. And I can come over here and I just have information about the launch pad. So if we look, we can see latitude, longitude, the status, whether it's still in use, the number of launches. And this is all information coming from that REST API. And so for example, then I can drill down and look at it. I can see, this is the one in the Southwest Pacific, and we can see just information about these things. So this was actually a failure. And if I click it, I'm actually going to jump into Wikipedia and just see some more information about it. But the takeaway is really, we're just making it a REST request. We're making it look and appear, as if it was just another relational database. And so things like Tableau, where it would have problems, with these different endpoints, it just makes it where it's just like another database, and all of the capabilities built into it, we're good to go with it. Anyway, that's what I wanted to show you, and I'll turn it back to Ken and Joelle.
That was a fantastic presentation from both of you. And just as I expected, we had some questions come in. So first two I want to jump to are kind of clarifying questions, one for each of you. Starting with Ken. When you were talking through your presentation, Ken, you mentioned about recipes. What do you mean by that?
Sure. So recipes is a term that I generally use which is synonymous with the REST configuration file. Essentially, that REST configuration file is that JSON document that Dennis just showed you towards the end of his demo that kind of defines how we set up the relational model that we got from the various endpoints that were added to the configuration file itself. So the reason why it's called a recipe is it basically gives you the starting ingredients or as like a template so that you would be able to make edits and modifications to that recipe for however you want it to be consumed in the future. So if there are
Otherwise
API
known as
changes
template.
excuse me?
Otherwise known as template, that kind of idea.
Exactly. Recipe template configuration file. So you can make changes as Dennis showed you within the user interface because REST endpoints are kind of a living document. They're never necessarily always static. So if something changes, you can just go back to that recipe, make the modifications, and you're back up and running.
Cool. Okay, thank you. That should help. The other person, this might be more for you, Dennis, while you were doing your presentation, you were showing get. You also touched on post, but this person was asking about put and delete.
So yeah, Autonomous REST Connector is select only, it's not full CRUD. So we would not support those other verbs. That's really not been an issue for the use cases I'm seeing. Most of what I see is around BI, business intelligence, also the extract portion of ETL. I've not seen a lot of requests for full CRUD, but those verbs you mentioned would be applicable to that. So they would not be supported at this point.
Just from a quick market perspective, the main use cases that we have been focusing on for use cases, data management or ETL, on the data integration side, analytics, business intelligence, and also application development for enterprise applications that may want to use a REST data source as a relational model. But that doesn't necessarily mean we haven't seen requests to support, insert, update, and delete. It just depends upon market demand, but it is on our longer term roadmap.
Okay. Yeah. And we do say this in all of our webinars of, we would love you all to just sign NDAs so we can tell you absolutely everything. But of course, it's a webinar, so can't do that. But we're going to do our absolute best to talk about future as much as we can. But you know the deal. All right, so lots of questions have been coming in, and folks out there in the audience, please keep them coming. I'm just gonna roll through what we've got. This person would like to know, does it support authentication via auth service providers such as Auth0, Okta, etc.?
So I didn't really cover it. We support, for OAuth 2, we support like authorization code, grant type, password, client credentials, and refresh token. But one thing we did see when we released Autonomous REST Connector is there are a lot of people who want to do things in addition to that. So we have custom authentication, where if you can integrate and authenticate with these other providers via REST calls, we would be able to support that and grab tokens from that. I've seen some fairly complex authentication, not specifically with something like Okta, but I have seen where people are grabbing credentials out of like a secure repository and then turning around them, using them and calling LDAP kind of REST requests over LDAP to get those authentication to happen. So we can support a lot of complex things. We definitely would want to look into that and see exactly what you're looking at. I don't know, Ken, if you have anything to add to that.
Very good summary. I think if this question is specific to leveraging some single sign-in capabilities from these identity providers, that is something that we're looking at as well.
Cool. Okay. So next question, we got a compliment, nice product. And the question is, are you saying we could from a web app fetch all client names that say begin with the letter M and by accessing directly the database table?
So we can certainly do that. It's a question of what the REST service supports. Hopefully, the REST service would support some kind of indexing where we could push a filter down just to get data back from M. If it didn't, we could do things like a like verb where we would say select asterisk from customers where cus name like and then M %. It wouldn't be ideal in that we would bring a lot more data back than would be necessary, though we could certainly handle that with our SQL engine. But the ideal would be if the REST service itself supported the filter push down, we would be able to grab it out of the SQL and push it down.
And just to add one more quick point of clarification, because I see at the end of that question was reference to accessing directly the database table. This product allows you to share your data via REST APIs, so you don't necessarily have to give your data consumers direct access to any type of backing data store. If you do want to provide direct database access from a web application, we do have a set of products within our portfolio that allow direct database access through ODBC or JDBC. But the Autonomous REST Connector is mainly just that bridge between SQL and REST APIs.
Okay, on to the next one. Some APIs need you to limit the number of requests you send per second. How can that be configured here?
That's actually a fairly common thing we run up against. Some of them will give you a 429 status code, basically saying you're flooding us with requests. You need to slow down. There is a configuration that can be added to the front of the that REST config file I showed you, basically saying how to handle different HTTP response codes. So for example, with a 429, sometimes the response will say, wait this many milliseconds before responding, before retrying, and we will honor that if it comes back. But if it doesn't, there are also a couple different algorithms out there for handling the wait time and the resend, and we can put those in. And I've actually demoed that where, you know, I talked about that read ahead parameter. If I set that high, I can actually flood a REST request and force a 429. And with coding to handle the 429, the you know, overrate, we can make it where you won't see an error, and it will pretty much maximize performance by pushing as fast as the API itself would handle. One thing that didn't come up in this talk is Autonomous REST Connector. It's actually built on the same framework we use internally to build our cloud data sources, the data, any kind of SaaS application. We build commercial drivers based on this same framework. So there's an awful lot in there from, you know, years of like the sampling and inferring data types and all that, but even things like where we were able to handle unexpected HTTP status codes. That's kind of in the heritage of the product, and that's why we're able to, you know, take advantage of it.
That's cool. All right. Next question. Does it work with Power Apps?
I'm not too familiar with Power Apps. I believe that's within the Microsoft ecosystem. If there's any way to integrate a JDBC or ODBC driver within Power Apps, and you need to connect to a REST API, that would be your formula for success here from an integration perspective.
Okay. And question asker, if that didn't cover it for you, just pop some more info in and I'll get to it. Okay, so this next question is coming from an OpenEdge customer. And for those who don't know, OpenEdge is another Progress product, just like DataDirect. So OpenEdge customer says they develop in App Builder and they want to connect to clients API to check product details between, I guess, the two of them, make sure that they're in sync. So can they develop OpenEdge programs to query data retrieved from clients using Autonomous REST Connector?
I'm no expert in OpenEdge, but what I do remember about the ABL language is it doesn't have a great support for ODBC and probably less for JDBC. So would have to look into this. In some ways, you may be better off with a native REST request from OpenEdge. I don't know. I've definitely seen some kind of shims put in place to do ODBC calls from ABL, but I don't think it's super natively supported. I don't know, Ken, have you seen that?
No, I haven't personally. I know there are some ways to get OpenEdge and the Autonomous REST Connector to integrate well for some various use cases, and you would be able to explore that with some OpenEdge staff, or we could help follow up after the call.
Yeah,
Yeah,
definitely.
definitely done some work with OpenEdge customers. Where we basically, they were using OpenEdge. They were using OpenEdge with REST services, and we use Arc on top of that to allow them to do BI. Sounds like you want to go from OpenEdge to someone else's API, but we'd certainly love to work with you on that, and we do a lot of work with OpenEdge people.
Yeah, and I should mention, if there are any questions that we don't get to today, we will absolutely follow up with you. And then if there's anything that maybe our answers didn't cut it for you somehow, we're happy to follow up on those as well. So there are lots of questions, so let's keep moving along. When there is a breaking change to the API, does it support versioning?
We don't support versioning inherently. It would be up to you, the end user, to do some type of versioning with the artifact, which is that REST configuration file. One thing that we do support is you would be able to resample. So if you go through the resampling process, which is that intelligent sampling process where we take a look at the response and we create that data model, that relational data model. If you make any changes to that data model, we do not overwrite those custom-made changes when you go through and resample. So if you know that your API has added a couple of columns, or maybe changed the name of a couple of responses within the JSON response, we would be able to handle those seamlessly for you.
Okay. Would we possibly use this for loading a data warehouse and transfer millions of rows?
Yeah, that's absolutely one of the use cases that we see is from a data consolidation or warehousing perspective, where you could use it for an ETL tool to do initial or delta loads. One of the variables within that equation that's really out of our control is the fact that we are only reading data from your REST API. So any type of service level agreements or objectives that the endpoint may have, you would have to respect. So we can only do so much as what the API gives us. But yes, you could, if you have an API that can return millions of rows without any type of response request limit, certainly possible.
Okay. So this one's a bit specific, so just do your best. Do you have any experience with integrating Autonomous REST Connector using IBM SPSS collaboration and development services using a JDBC connection?
I don't specifically with that IBM product, since one thing DataDirect does is adhere very strictly to the JDBC specification. So we're going to make this REST request, this REST data source look and behave like a normal JDBC connection. So based on that, I would feel, very likely that you wouldn't hit any problems. I know some other IBM products like Cognos have actually have embedded Autonomous REST Connector. So we definitely work with IBM.
Okay, good job. So another open-edged kind of flavored question, is the tool capable of generating 4GL source code to be used in specific open-edge applications?
We're not generating any source code. Basically, we're putting a wrapper over a REST API, and we're making it, giving an ODBC SQL or a JDBC SQL connection to it, but really not creating code.
Gotcha. Okay. And actually a follow-up question to that, and I guess we might know the answer now. Do you store any of people's data in the UI?
We don't store data, no.
No. Okay. It's what I expected the answer to be, but just in case. All right, if a connection data set is published to Tableau's server, is SSO supported? For instance, once a user logs into Tableau and views a dashboard, do they need to log in again to view the data from the progress connection? Did that come across okay?
Yeah. So that's actually one where I've seen people do different things. It can be complicated. We don't support SSO out of the box at this point. There are things Tableau is doing with Tableau connectors or taco files, and we're looking into those a little bit, and there is some authentication kind of built into that, and potentially limiting re-sign-ins, but we'd have to, something we're kind of working on right now and seeing some success in it, but some of that even depends on the level of Tableau server I've seen too.
Okay. So this person is asking about an internal API. Do they have to do anything special for that versus a public one like what you were showing?
No, I mean, there are some specific REST API requirements that we do support just kind of out of the box. Right now, we support JSON responses. We do not support XML, but that's certainly something that we're looking at supporting in the future within our roadmap. And it's a read-only driver at this point in time. So whether it's an internal enterprise-facing API or a public API, like the SpaceX example that Dennis showed, as long as it's well-formed, JSON, it should work.
Okay. So questions are starting to slow down. So note to the audience, if you've got more, we can stay here for a bit longer, so just keep them coming. But I'm going to go through what I see here now. So this person says, how is Autonomous REST Connector different from what they're doing in the application using OpenEdge? And that uses inbuilt .pl files. I hope I'm saying that right.
I don't think we have enough OpenEdge experience between Dennis and myself, unfortunately. So we can always try to find a way to follow up after the call specific to this OpenEdge question.
Yeah, because we would definitely work closely. I know I do with the OpenEdge SEs, and we can kind of see who you're working with and talk about it.
All right, never fear, question asker. We've got you. Is there a way to configure any rule-based access control?
Rule-based or role-based? Well, whether it's rule-based or role-based access control.
RULE, sorry.
We don't
Southern
support
pronunciation.
rule-based access control. The authentication mechanisms, and that's mostly, I think, found within identity providers. And so if your identity provider supports OAuth 2 or basic or token, whether it supports one of the ones that we support out of the box, we would be able to support that inherently, but we don't implicitly support rule-based access control within the driver itself.
Okay. This question is about a tutorial that was up on the website, on our marketing website. And my personal hunch as the marketer in the room is that this might have been one of our pre-Autonomous REST Connector UI tutorials that you were looking at. There is another tutorial on there at this point in time that includes all the steps for this brand new UI. So if that doesn't help, please let us know. But yeah, if you go into the tutorial section and look up at the very, very top of the list, that's probably where you're going to find what you're looking for.
I see this question. So just from a timeline perspective, we've been working on this major feature, the user interface. And really the goal is the long-term goal is we really want anyone to be able to build a driver to a REST-based data source under an hour without having to code, without having to custom code a solution that may only work with a single set of APIs, but to take a look at an API from a visual perspective, configure it, tune it, and validate it, and you should be done within 60 minutes. Well, sometimes the devil's in the details, and it may take a little bit longer based upon some difficulties you may run into. But this UI was released, I think, about two weeks ago. So it is now generally available, and anyone that may sign up for a trial today will get access to the UI that Dennis showed.
Yep. Okay. Windows or Linux installation? And is there a Progress hosted version?
There is not a Progress hosted version. I believe the UI will work on Linux. I actually did it on a Mac just now, so I've not personally tried it. I don't know, Ken, have you?
Mac is not an officially supported platform, but I run it on my Mac as well, so it's unofficially supported. But it basically it's a Java application, so it basically runs up in a web browser. Hosted version, that would be an interesting use case to talk to whoever asked that question after the session today. It's something that, it's obviously something we're thinking of as some type of self-hosted solution from Progress perspective, but right now it's a deployable product either on-prem or within one of your favorite cloud providers, wherever you want to install it.
Okay, so we are getting short on time. So I'm going to take this one last question here, which is a really good segue. The licensing model and cost, well, that depends on who you are. So we would absolutely love to work with every single one of you out there today. Have you get in touch with a salesperson or your existing account manager, whoever that may be, to introduce you further to Autonomous REST Connector, answer any questions you might have, and in addition, be able to run some quotes for you so you would know in your specific situation what kind of prices you're looking at. So just to wrap things up, Dennis, Ken, is there anything that you're saying, oh man, I wanted to tell them this, because this is your moment?
I mean,
unbelievably, we covered everything we needed to.
And did a great job. All right, so that is it for everybody. Come visit us at DataDirect. You're more than welcome to take a trial, just like Ken was saying. Autonomous REST Connector is the product we were discussing today. We have lots of other great products as well. And we thank you so much for being here.
Thank you.